we're going to take a little extra time on applying rational functions. Okay? Number one, the applications, the real, quote-unquote, real-world applications, also helps us review solving rational functions, rational equations. Okay? So we worked on that last time we met. We're going to work on applying the rational functions, which will help us review actually solving the rational functions as well. Okay? So let's read through problem number one. In order to create tunnels, civil engineers devise plans where tunnel boring machines begin drilling at both ends of the tunnel and meet somewhere in between. A tunnel is being built through a section of mountain. One tunnel boring machine alone can finish the tunnel in 4 years. Another machine can finish the job in 3 years. If both machines start at opposite ends and work at the same time, when will the tunnel be finished? What do you think is the most popular incorrect answer? Just looking at it. 7. 7's the most common incorrect answer, because what did they do? Well, does it make sense that you would add it together?
No.
I mean, kind of a little bit of sense. It's one and the other one.
Yeah, but you're working together.
Exactly. So first of all, can you see where they got that wrong answer?
Yes.
But second of all, you're arguing with me, which is good, because you can say, well, yeah, I can see it, but that's not even logical, right? Okay, so that's a good start for us. That bodes well for us today, okay? So if we can, partly because you guys are arguing and saying if both of them are working at the same time, it should be shorter. It should be less, right? It should be less than both of them can do it individually by themselves. Because we have a tunnel. We have a mountain that people are trying to drill through, and they're going the same direction. So it shouldn't take them 7 years, or even 4 years or 3 years, right? Okay, so we got to figure out how to set this up. Is this a real-world problem that you might encounter in your job after you graduate college? Probably not for most of you, right? But could you see how, like, a civil engineer or some sort of worker on a mountain could see this problem, right? Okay. So, would you consider it a real-world application? Yes. Okay. Good. All right. So let's think about it this way. I have one job, and I can do it in 4 years. But the other one can do the job in 3 years, right? But what are we saying? What are we asking the machines to do? Work together. So what do you think I should do with these two? Add them. Very good. We still have that one job. How long is it going to take for them to do it together? Right, that's what we don't know, right? What do we usually call something we don't know? Yeah, X. It's our variable, right? And what is X going to stand for? So the number of years. So years is what we're going for, right? If both machines are working together at the same time, that's what our X is going to stand for. How many years that it takes if they're working at the same time. Okay? Now, last time we met, we talked about if we had a choice between working with fractions and not working with fractions, what do we want to choose? We want to choose not working with fractions, don't we? Okay? Well, we can accomplish that fact by deciding if I were going to add these together, what would be my common denominator? Okay? Somebody's saying 12. That's really close. What am I missing? The x, right? So let's make our common denominator 12x. But here's the thing. I didn't decide on what my common denominator was to actually get a common denominator. I decided on my common denominator to get rid of the denominators. That's what I want to do, right? So what if I multiplied each term by 12x? Now, just to be clear, aren't I multiplying both sides by 12x? And then didn't I distribute that 12x times each term on this side? Okay, just wanted to make sure with that. Okay? We talked about that the other day, about how we can skip that step if we understand the math. I was just making sure you understood the math. Okay? So what happens right here in this first fraction? Let's just look at the first one. What happens? 12x over 4. Does that simplify at all? Oh, it does? What does it simplify to? 3x, right? The 12 simplifies to a 3, and the 4 simplifies to a 1, and I'm just left with 3x. What happens with this middle fraction? 12x over 3, what does that simplify to? 4x. Or from the beginning, I could have simplified that to a 4 and a 1, which would be plus 4x. What about the last one? Does anything simplify? Right, because the x's simplify, right? And I'm left just with 12. Does that look like a much easier equation that I can solve? Okay, 3x plus 4x. Yes, 7x equals 12. How do I solve for x? Okay, can I tell you something silly? Earlier I said, okay, what is 12 divided by 7? And they dutifully punched in 12 divided by 7, and they said, it is 12 sevenths. Okay, what was I actually asking for? The decimal, right? The decimal equivalent. So there's at least 2 ways. There's 3 ways that I know for sure, but 2 that are faster than the others. And you can press 12 divided by 12 divided by 7, control, enter. Right? Do you know that one? Do you know the other one? 12 divided by 7, decimal, enter. Because I entered a decimal as part of my number, so it's going to give me a decimal answer. When you do that, what does x equal? 1.714. So let me ask you this. What does this solve? It solves the equation, right? After I find the solution to the equation, that's exactly right. I have to answer the question. The question is asked to me in a sentence. So how do I want to answer the question? In a sentence. How are we going to answer this question? Then tell me. It will, I can't write that fast, take 1.714 years. Is that enough, or should we add one more word? Does that make sense? So, while a lot of people think, oh, I'll just write the word years on this, that tells me kind of you think you maybe know what this means. This shows that you truly know what question you're answering. Does that make sense? To one person? Okay, excellent. Just teasing. Okay. Any questions about that problem? There were some people earlier confused about why we put them in fractions. Why didn't we just do 4 plus 3 equals x?
That's wrong.
Well, it is. It is wrong, right? But we already talked about 4 plus 3 equals 7, and we know 7 is not the right answer, right? What kind of functions are we dealing with right now? Rational, which implies they are rational or fractions, right? Does everybody see their ratios? One job takes 4 years. 4 years per job, 3 years per job. Yes? Okay. So let's look at number 2. You ready to go on to number 2? Okay. Tobias drives 30 kilometers in the same time that Alicia drives. Did I say 30?
Yes, ma'am.
Sorry. Tobias drives 300 kilometers in the same time that Alicia drives 200 kilometers. The speed at which Tobias is driving is 20 kilometers per hour more than the speed at which Alicia is driving. Find the speed at which Tobias is driving and the speed at which Alicia is driving. Before you can do this problem right here, there's a formula that you need to know. Have you ever seen that formula before? You should have in 8th grade. You should have in Algebra 1. And several of you have seen it in physics, haven't you?
Oh, yeah.
Yeah. Okay. What does it mean? What do the variables stand for? Distance. Equals. Yes, that's what those 2 lines mean. What else? What else?
T is for time.
The T is for time, so all we need is the R.
Ratio.
It's the rate, right? The speed at which they're traveling. Okay? It was a good guess. Okay? So let's look through this problem and see what we know. How about that? What do we know about Tobias? He drove 300 kilometers. What do we know about Alicia? She had 200 kilometers. Okay, what do we know about Tobias's speed?
20 more.
It's 20 more than hers. If his is 20 more than hers, how fast was hers?
20 less than.
Don't go that far. It's a good thought, but don't go that far. Okay? If his is 20 more than hers, where do we have to start? At hers. And do we know it? So what do we call it? X. Her speed is X. If her speed is X, what's his speed?
20x.
Close.
20 plus X.
20 plus X.
So close.
Okay? Now, so we know their distance and we know their rate. Do we know their time?
No.
We don't know their time exactly, but we do know something about their time.
The same.
It's the same. And that is important. It's super, super important. Okay? Because if I take this equation over here and solve it for time by dividing both sides by r, I get t equals d over r. If Tobias's time equals d over r and Alicia's time equals d over r, shouldn't their d over r's equal each other since their times are the same? Well, what's Tobias's distance?
300.
What's his rate?
26.
So d over r equals, what's her distance?
200.
And what's her rate? Huh.
Oh.
How do I solve an equation that is one fraction set equal to another fraction? Yeah, and that's the only time we can use that, isn't it? So if I cross multiply here, what do I get? 300x. And if I cross multiply here, what do I get? So I would get 200 times 20 plus x, right? You guys are trying to skip a step, which you know is totally fine with me. But I want to make sure that we know where it's coming from. Because you were saying 4,000 plus what? 200x, right? Because we distributed the 200 times the 20 and then times the x. So how do I solve this equation? Oh, you would subtract 200x? Okay, me too. And I would get 4,000 equals 100x. If I divide both sides by 100, x equals what? 40. Now, 40 is the answer to the equation. Can somebody tell me the answer to the question? Tobias drives how much? 60 what? Kilometers per hour. Alicia drives Whoops. You want to know something silly?
Yeah.
They didn't want this earlier. They wanted this. I said, okay.
Okay.
You're okay with that. I'm okay with that. We're good. Okay? Any questions about this? Okay. You ready for your homework?
Yes.
3 and 4.
Oh my God, that's the worst.
I know that there are 4 problems on the back. They are not for extra credit.
Oh.
They are for tomorrow. Remember I told you we're going to spend a little extra time on this?
Yeah.
Do these 2 problems for homework. Problem number 3 is much closer related to problem number 1. Problem number 4 is also related to 1 and 3, but it's slightly different, so pay attention to that. Okay? Any questions?
No, no.